Hi, this is at 1 with 0, and welcome to my neighborhood. Today, I'm going to go through some of the articles that I'm reading right now, and I want to take a look at 3, hopefully, that I'm interested in reading. I'm trying to get motivated to read at least one of them. I think they're interesting, but, I'll let you be the judge. And then the other thing, what was the other thing? Update on the silly problem that I'm solving. I don't know why this would be useful, but let's say you start in San Diego, and you ask yourself, or you ask whomever, from San Diego, if you're driving, you're not allowed to go off-road. How far can you get in the country? Of course, you could go to Canada and back and inflate that number, a lot. So within the continental United States, what are the extremal paths? And then in San Diego, we'll end up somewhere. I think it's Bellingham. I'm not sure. It's on the East Coast. And so there's gonna be some towns where a lot of routes end there. There's only one beginning for each route, but they all end. There's groups of them. Some of them end here. Some of them end there. One of the articles I'm reading, how do I even explain what this is about? It's gonna help me to do it. So this is 50% for you and 50% for me, because when I explain it or talk about it, and makes it easier to understand. For any theory T, so theory, I believe a theory is just the modus ponens closure of a set. What is that? The modus ponens closure of a set means that if there's a statement, now these are sets of statements, propositional variables. If you go, God. Yes, if for any theory, a theory is closure under modus ponens. Modus ponens is something that your brain just knows already. Actually, a lot of math is inspired. The discovery is inspired by our own brain. Trying to decide what to say here. This is just gonna be crazy. K is axiomatizable over T. So this is the definition. The definition of axiomatizable over something. So K is axiomatizable over T if and only if, for some set gamma of L sentences, K equals the L mod class of T union gamma. That's what I want to understand. I mean, when I read that, I do kind of understand it. An L sentence is just a statement with no free variables. Free variables, I think, are kind of interesting in logic. So you have free variables and bound variables, and I forgot which is which. Anyway, I think free variables are not within the scope of a quantifier. There's two quantifiers for all. So that quantifies like everything, all. And then there exists is the other quantifier. And actually, based on there exists, you could come up with a way to say there exists only one, or there exists only two, with some property. So if T is the minimal theory, we call K simply axiomatizable or finitely axiomatizable. Why can't you just say axiomatizable means that, so if the theory is axiomatizable, so K is axiomatizable over T if K is in the fucking consequence closure of T. That's it. Like, and then a K is a set of axioms, like any subset of Y is a set of axioms, right? Or Y0, a set of axioms. So I don't know if I buy this. And you always, like, math is the same as, the newspaper. You always have to be incredulous about and circumspect about what you read in a newspaper and what you read in the math paper, even if it's a book. Because it could be flat out wrong, or maybe it's not exactly what you think it is. So be careful. In this terminology, the results of L equals mentioned above read the classes. Jesus, how am I going to read that? I'll just do one. Well, I want to skip to the interesting one. I'll just say under the right conditions. There's actually like several that would be very hard to read and explain. So one of them says that this is gonna be strange, even for me. I think this is called the Lowenheim-Skolem theorem, but I'm not sure. They just say it's proposition 3.52. If T has finite models of unbounded finite cardinality, that is, for all n in omega, this set of natural numbers. So for all natural numbers n, T has a finite model with at least n elements. Then there's three things that are true if under those conditions. So assuming for the sake of our argument, T has infinite models. The model class of T intersection of the set of A such that A is finite is not axiomatizable over T. So that's an bad, but I find it interesting. You can't axiomatize it. Now, does that transfer over to the definition that I had, where axiomatizable just means it's in the consequence closure of somewhere in the consequence closure of a set of statements. I guess the world will never know. So I'm about to stop this. Oh, this is the picture that I made. The problem was, take a city like Denver, and then tell me every city that's 100 miles away from Denver. So there'd be kind of a circle. I did actually succeeded in that problem, doing that problem, and this is the concept that I was looking for. Of course, it's not shaped like that in real life. There's mountains and shit, but yeah, have fun and do math.